All right, good day, class. So today we continue with a very short one. Okay, so that tomorrow won't be too long. All right, so okay, so last video we have complete the parametric equation of hyperbola. All right, where it is in trigonometry form, means x equals a secant theta and b equals tangent theta, or x equals a tangent theta, y equals b secant theta. All right, it depends it's the horizontal one or the vertical one. All right, and of course also it can be represented by the parameter t, other than this. So today we will go to okay, sorry, for the hyperbola, yeah, the parametric equation can be represented by the trigo one or by the parameter t. Okay, so today we are going to see 5.2.4.3 parametric equation of rectangular hyperbola. So still remember rectangular hyperbola, right? It's like this. Okay, this one. Remember last time, let's say it's a hyperbola, vertical hyperbola, let's say like this, and the axis is this one. So when we rotate, remember when we rotate it 90 degree, all right, then the asymptote become the xy axis. Okay, then it become like this. So we call this rectangular hyperbola. And before this, actually we name it as reciprocal graph, which is in the form y equals 1 over x. Okay. So for rectangular hyperbola, so the rectangular hyperbola, the standard form of the equation will be xy equals c squared. So remember, and can also be defined using the parametric equation. This is the parametric equation for rectangular hyperbola, or only rectangular hyperbola, which is x equals ct and y equals c over t. T can be any real number but not 0, because for the parameter y is c over t. Okay, and where is the c? C is this one, where it is in the standard form, xy equals c squared. So c is from here. All right. So to prove this one, very simple. So x is ct, right? Y is c over t. So when I multiply x and y, means I multiply ct and c over t. So t and t simplified, therefore you get xy equals c squared. So it's just very simple to prove it. So remember, this is special for rectangular hyperbola only. Okay, so then any point lying on the rectangular hyperbola can be represented by this parametric coordinates, ct, c over t. Alright, so let's see some example. So example 5.2.4.3, find the loci of the following points. So you are given the parametric coordinates. So they want you to find the Cartesian equation. All right, so just very simple. This one before this. Okay. Before this, just now I haven't finished this one, right? The rectangular hyperbola. So xy equals c squared. So the parametric equation is x equals ct, y equals ct. So this is for center at the origin. So how about if center not origin? So if center not origin, the standard form of this rectangular hyperbola will be x minus h, y minus k equals c squared. All right, then the parametric equation will start from x minus h equals ct and y minus k equals c over t. So later, of course, you shift your h to this side, you shift your k to this side. All right, okay, so let's look at the example. All right, first question. So we are given the parametric coordinates p. So p is 2t, 2 over t. All right, so x equals 2t, y equals 2 over t. All right, so compared to the standard form. All right, this one, compared to the standard form. So your c is 2 lah. All right, so if your c is 2, so the Cartesian equation of this rectangular hyperbola will be xy equals c squared. So c is 2, so 2 squared is 4. This is one of the way. You recognize the c, then you sub in. Or you can do like this. This is x, this is y. So I multiply xy. So means I multiply 2t and 2 over t. So t and t simplified. Yes, then you get your Cartesian equation. All right, also can. Okay, B, point Q. This is point Q. All right, so this is x, this is y. So very clear compared to the standard form. All right, your c is 3 over 2 lah, ct, okay, c over t. So your c is 3 over 2, therefore xy equals 9 over 4. Oh, square ma, c square ma, so 9 over 4. And normally if right hand side involve fraction, so we will move the 4 to this side lah. So write in this way. All right, look nicer lah, neat, more neat, okay? Then second question, for each of the following curves, obtain its parametric equation. Just now you are given parametric equation, you find the Cartesian. Now you are given the Cartesian and you are asking to find the parametric. All right, so question 2a. So you are given 25xy equals 64. All right, so we move 25 to this side. So it's 64 over 25 and we write it in the square form. All right, so it becomes 8 over 5 square. Okay, so from here, I know that what is my c. Therefore, the parametric equation will be ct, so 8 over 5t, and c over t, so 8 over 5t. Oh, just like that. Okay, so question B. So you are given in this form. So 4 means 2 square lah, so your c is 2 lah. And when you see this thing, so you know that the origin is not, the center is not origin. The center is 1, 2. So when you want to find the parametric equation, so it becomes x minus 1 equals ct. See? Excuse me. Then y minus 2 equals c over t. Then I shift minus 1 to this side, I shift minus 2 to this side. So these are the parametric equation. All right? Okay, so for question C. All right? Let's see. Okay. So question C, this is the Cartesian equation given. So I see y square and 6y, so I group them together, then I factorize, I completing the square. It becomes y minus 3 square. So negative 3 square is 9, so it's something excess, so minus 9 lah. So it becomes like this. So what is this? Is it hyperbola or rectangular hyperbola? No, it is not, right? Because rectangular hyperbola, you don't have square. Okay? You don't have any square. All right, so what is this? Think for a second. What is this actually? Yes, only y square, right? And x. So this is actually parabola. Parabola. I don't know why I put into this part. So it's actually parabola. Okay? All right. Okay, so question 3. Find the Cartesian equation of the following curves. So same, they give you the parametric equation and you are asking to find the Cartesian equation. All right, so what we have discussed just now, what are the questions that we have discussed just now? You see all the parametric equation, the t is positive. This one parameter q lah, but it's also positive. Okay, so for this question 3, you see that the parametric equation is in negative. The t negative, see, negative. Okay, so what happens if it is negative? All right, so let's see. I start with question 3a. You are given x equals 2t and y equals negative 2 over t. All right, so this one, 3a. Okay, so same, we use the method just now. Since they are given us the parametric equation, so we start with x multiplied y. So 2t multiplied negative 2 over t. So t and t simplified. So now you see your equation is in the form xy equals negative 4. Alright, so when I want to find what is my c, I can write in this way. Xy equals negative outside, bracket 2 square. Alright, so the c is 2 lah. Maybe because you will say, negative 4, how to write it in square form, right? So it's actually like this. Alright, so if this c square is negative, what happened? It's just that the graph like this only. Alright, so check just now. This one is where the c is positive. Where the c is positive, the graph exists at the first and third quadrant. Where you see both x and y positive. This one, both x and y negative. So negative multiplied negative, positive lah. Okay, so for this one, if c is negative, then the graph actually exists in second and fourth quadrant. You can see. Okay, second and fourth quadrant. You see, at second quadrant, y positive but x negative. So positive multiply negative, negative lah. Oh, so you should get negative answer. This one also, fourth quadrant, x positive but y negative. So positive multiply negative, so you should get negative answer also. Alright, it's just like that. Alright, so B, I want you to do as homework. Alright, this is B. X equals 4t, y equals 1 minus 4 over t. Do it as homework, and I will discuss C. Because after I discuss C, you're supposed able to do B lah. Okay, so this is C. Alright, you are given the parametric equation x equals 1 plus t, y equals 2 minus 1 over t. Alright, so if you see numbers, then we will move it to the left hand side, become x minus 1 t. This one also, move the 2 to this side, x minus 2 t. Negative 1 over t, sorry. Alright, then you multiply them, x minus 1 multiply y minus 2. So actually, as I say, when you see the parameter t plus minus something, means the center is not at the origin, it's at some other points. So this one, very clear. Okay, so center is at 1, 2. Okay, so then t multiplied negative 1 over t lah. So t and t simplified. So you see your right hand side is negative 1. So negative 1 means it's supposed at second and fourth quadrant. Okay, so I show you the graph. Alright, so xy axis, then center is 1, 2. So this is the center, 1, 2. This is the center. Alright, and the horizontal line and vertical line passes through the center will be your asymptote lah. Asymptote. Okay, so because this is the right hand side is negative, so I know that the graph is at second and fourth quadrant. Okay, where it is at second and fourth quadrant like this, so you see it cut y-axis. So you calculate lah. At y-axis, x0. So when x0, y equals 3. This one also, it will cut x-axis. So sub y equals 0. So when you sub y equals 0, then it's 3 over 2. Alright, so this is the graph. Okay, so that's it for today. Very simple. So after you complete this video, please do question 2, this one, as a homework, and one more extra. This is not in the notes, you copy down. Okay, one more extra D. Alright, so do these 2 questions only, B and D, as homework, and please learn, sketch the graph. Sketch the graph, show the graph. Alright? Okay, thank you class. So I will see you tomorrow.